Hi Trigoners, this is Quiz Review 3.4 and we're going to start with the first problem. It says a fountain shoots a drop of water into the air with an initial velocity of 30 feet per second from ground level. So this is a projectile motion formula problem. We have, notice we have a negative 16t squared plus v naught t plus s naught is equal to s of t. So s is the height above ground and 16 has something to do with gravity. Right, and we have our units are feet and seconds. V naught is initial velocity and S naught is initial height. So we have our equation. We're going to go ahead and type this into our calculator. So the first thing I do is go to y equals and type in negative 16x squared plus 30x. Now I think about a window. So I'm thinking, how long does it take for a drop of water to come out of the ground? I'm thinking 2 seconds should be plenty. And then how high does it get? Well, over here in part C, they're talking about 4 feet above the ground. So that makes me think that, I used 15 feet. That should be good. Let's take a look at the graph. So we need to find the maximum. So we'll calculate maximum. So make sure that you go left of that maximum y value and hit enter. Go ahead and move to the right of that y value, that maximum y value, and hit enter again. And then let's back up a little bit. So notice that our, our maximum is at 0.94, 14.06. So the maximum height for part A would be at 14.06 feet. Now they want to know for part B, how long will it take for the drop of water to hit the ground? So you want the height to be 0. And you probably could solve this one algebraically without much trouble at all. Oops. By factoring out a t. Or you could have also found this point here with the calculator. So let's practice doing it that way. The easiest way might have been for you to go to y equals, and in y2 you could have typed in 0. And now when we go back to the graph, you could go ahead and find the intersect. There's a line there. So calculate intersect, or you could have used the 0 feature. Enter, enter. Enter. So let's see, 1.875. So again, same answer. So either way, let's do part C now. It says, when will the drop of water be less than 4 feet above the ground? So this time we'll let y be 4, and we need these two values right here that intersect with the graph. So we'll go back to our calculator in y2. Let's type in 4. And if you do intersect, I will tell you that this is t equals 0.14 seconds and t equals 1.73 seconds. Let's just go ahead and check one of them. Oops, no, I don't want that. So if you go to calculate, intersect, and hit enter 3 times, and you get 1.73. So this time though, I wanted to know for part C, less than 4 feet above the ground. So that's at 0 seconds to 0.14 seconds, and then 1.73 seconds to the time that it hits the ground, which we already found was 1.88 seconds. So that's number 1. Let's go ahead and think about number 2. It says an icicle drops 50 feet from the roof of a building. So we're using our vertical motion. Notice that we have an initial velocity of 0. So we have the initial height was 50. And we want to figure out when it hits the ground. So when it hits the ground, the height is 0. So we're saying 0 equals negative 16t squared plus 50. So this one Wouldn't be that bad to solve algebraically. You could do that. I probably wouldn't graph this one, but I mean, you could if you want to. But this is probably quicker just to solve algebraically. 1.77 seconds to hit the ground. All right, why don't you go ahead and pause the video now and try number 3. See if you can decide what will be your y values, what are you graphing with respect to x, and maybe try and write an equation. Okay, so for this one, if we have a value of x, then the opposite side must be 12 plus x, and we know we have 100 feet of fence, so we subtract the 12 plus x and the x that we use. We're not putting a fence in front of the shed. So 88 minus 2x, well, we divided by 2 because we have 2 sides. These will be congruent. So that's why we have 44 minus x and 44 minus x. So if we want to find the area, we could type this into our calculator now. There we go. We're graphing area with respect to time. So I'm expecting the graph to look something like this. Let's go ahead and think about a window. So notice if you have 100 feet of fence, again, you could just kind of think about what would make sense. Like, could you have 50 feet here and 50 feet here? Notice that would take all the fence, so that wouldn't work. But maybe you could have 20 feet and 20 feet. That's 40. You'd have 60 feet left over. So, I mean, I think that would make sense if x was approximately 25. So when we look at our calculator now, we could see if that works out, 0 to 25. And then for our y values, that's our area. So if the x, for example, was 25, you would have approximately, 37 times approximately 20. So let's see how big that is. Oops. So again, if x was approximately 25. Okay, so that is about 925. So if that makes sense, maybe go a little bigger, maybe, I don't know, 2,000. Okay, so let's see if that was a good window. Okay, so I don't know if that window was really that great. So let's take a look at it. Was 0 to 25. I mean, maybe you might want to go a little bit bigger for the x's. And I mean, I guess the y's were okay, but maybe go a little smaller for the y's. The window wasn't terrible. Okay, let's take a look. I mean, not horrible, because we're really just trying to find the maximum. So that would work. Let's go to calculate maximum. Go left of that maximum value. Go to the right of the maximum value. And actually, the other window would have worked fine, just as long as we can see the vertex. And then back up. And the maximum is, so when x is 16, y is 784. So that means when x is 16, we have 28 feet, and then 44 minus 16 is actually 28. So 28 feet by 28 feet, those are your dimensions. So 28 feet by 28 feet and a maximum area of 784 square feet. Okay, so that was number 3. Let's go ahead and turn the page, and we are going to look at some problems. These are maybe not some application problems. These were from the beginning of section 3.4. So go ahead and take a look at number 4 and think about how you would write an equation for this parabola graph. Go ahead and pause the video and think about that for a minute. So for me, whenever I'm given the vertex, I would use vertex form. And in this case, we were given the vertex because the vertex is at 1.5, comma 1. So we have y equals a times x minus 1.5 quantity squared plus 1. So we're going to take some other point. How about this one? 1, comma 0. Temporarily put 0 in for y and 1 in for x. Now we could find a. Subtract the 1. We have 1/2 squared, which is 1/4, so multiply by 4. So a is -4. So we have y equals -4 times the quantity x minus 1.5 squared plus 1. So there you go. There's the equation in vertex form. Now for the next problem, they want you to write an equation in vertex form. So you're going to have to complete the square. So go ahead and pause the video and give it a try. See if you remember all the steps to complete the square. You subtract 1 from both sides of the equation and to factor out a -2. So the next thing that you would do is so now we have to decide what number will we add to make this a perfect trinomial square. So the middle term is 4. If we divide 4 by 2 and square it, we get 4. So you have to keep things balanced. The only thing is you didn't really add 4, you added -8. So you'd have to add -8 to the other side of the equation. So now we have y minus 9 equals -2, and we're going to factor. So we have y equals -2 times the quantity x minus 2 squared plus 9. Okay, let's try number 6. So for number 6, I'm going to write an equation of the quadratic. Now notice they gave you the x-intercepts. This would be really helpful, I think, to draw a little picture. So the x-intercepts are at -4 and 2, and there's a maximum at 10. So that means that the parabola must open down. For this problem, we could find the vertex because the vertex must be halfway between. So the axis of symmetry is halfway between -4 and 2. So that would be at -1. So that means that we have a vertex at -1, 10. So since we have the vertex, I would use vertex form. So go ahead and pause the video and use either one of these x-intercepts to find the a. So if we use the point 2, 0, temporarily put 0 in for y and 2 in for x. If we subtract 10, so we know that a is -10/9. Okay, let's take a look at the next problem. Now for the next problem, we do not know the vertex because they told us that the x-intercepts were at -5 and 7. But again, they didn't tell us the maximum point. They did tell us that there's a point at 0, 3. That's how I know that there is a maximum and not a minimum, because there's the y-intercept is positive. So the problem is we don't know the vertex. So we're going to have to use factored form. So you're going to have to somehow find a. So let's use this point 0, 3. So go ahead and pause the video and substitute 0, 3 for x and y and find a. So the a is -3/35. Let's go ahead and look at our very last problem now. So for this one, we need a graphing calculator. So let's go ahead and do this one together. Go ahead and grab your calculator, and we'll go to Stat, which is in the 3rd row, 3rd column. We want to edit because we want to enter some information into the calculator. So you have a choice. You could either delete each line one at a time, or you could go to the very tippy top of the list and hit clear, enter, and it will clear the entire list at the same time. So we want to enter our x's into list 1. And the y's in list 2. Be careful that the corresponding x's are next to the corresponding y's. So we have 9, and that's 2, 9, so that works 3. And -1. Okay, let's see how that worked out. Perfect. Okay, so now we're going to go to Stat. Now everybody's calculator is a little bit different, but if you go to Calculate and you have an older model, you could just hit quadratic regression and hit Enter again. But the newer models look something like this. Now, if I wanted to store this, I could go to vars and then type in y equals, but I don't think we even need to do that right now. We're just going to calculate. And there's our equation, y equals x squared plus 3x minus 1. Nice job, everybody.